Welcome to Aorb Tech. This is the fourth installment in the Learn to Pi series. Today we'll be discussing strings. Let me go through a brief outline of what we'll be discussing in today's episode. So we'll be looking at syntax, concatenation, slicing, functions, special characters, raw strings, and string interpolation. So let's look at the definition of a string. What is a string? A string is a data type in programming, and as discussed in previous episodes, a data type is essentially the kind of data that the computer stores, and variables can have different data types. So a string is a data type that's commonly used for text in programming, for expressing text and for storing characters. Specifically in Python, a string is an ordered sequence of characters enclosed in quotation marks. What that means is that essentially you have a long list of characters and they each have their own index, which is a number that's associated with that character in the string. In practice, what this means is that you can have a lot of characters, which are basically just symbols that are represented by a computer. So when you think of a sentence traditionally, each word in that sentence has a letter inside of it. A character is kind of like that letter. But a character can also be a special character, for example, like a space or like a full stop or like a comma or an apostrophe. So characters can be a wide range of different symbols or letters or numbers. So in Python, there are three main ways that you can define a string, and they each have different use cases. So maybe not the most common one, but the first one that you learn is to use single quotation marks. And this is for situations where you just have text. You have text and numbers and maybe some other special characters and some characters that we'll learn about later in this episode. So let's create a variable here. Let's create a string variable. And Python knows that it's a string because you use this syntax. You use these quotation marks. So you use single quotation marks, use double quotation marks, and you can use triple quotation marks. And I'll go over which situations you need to use each. So let's create an example string. So this one is going to say hello world. For this example string, we're going to use single quotation marks. So now let's print that, and you'll see that's the result. So you can actually use strings in the print method, and so you can put them in here. In the previous episodes, we used this kind of notation, where we would put inside of the print method a string, and that's what would be printed. And this is actually equivalent, this notation is equivalent to this notation, except that whatever value is stored in this variable will be used in this method and will print that text that is in that string. So we have that over there. So let's say that's all cool and interesting, but let's say I want to have another string and I want to describe something else. Let's say I want to talk about someone's house, for example. So let's have another string here. String 2, let's say. And that's going to be Eric's house. But then we run into a sort of problem. We use an apostrophe in the string, and the way Python recognizes strings is that there's two apostrophes and between them there's some text. But if you have another apostrophe in there, Python kind of doesn't know what to do with that. So the solution to this is to use double quotation marks. And so let me just put those in here, double quotation marks, and then we can now put single quotation marks inside of the string, which is very cool because now I can print that string too. And this is what we get, Eric's house. Very cool. Okay, again, very awesome. But let's say I want to put now double quotation marks inside of the string. Well, okay. So the solution to this, as you might have guessed, is to use triple quotation marks. So let's create another variable, another string. Let's call it string 3. Or maybe let's call it quote, because that's the situation where you'd use double quotation marks the most. So let's have triple quotation marks here. So Python should automatically, or depending on the IDE you're using, or the environment you're using, it should automatically put in the second half of the quotation marks, the closing quotation marks. Now let's put in a quote here. So he said, hello. And then he said it gently. So we'll have that. And then we can print the quote. And as you can see, the output contains double quotation marks. So there are three main ways that you can define a string. And they have different use cases depending on if you want to use single quotation marks or even double quotation marks inside of those strings. Another thing I want to look at is a built-in function in Python that allows you to see the data type of a variable. So let's say we define another variable. Let's call it house. And in the house, we'll have some address. Let's just randomly put in some letters. GU23-SW61. So that's a pretend address and a pretend country and a pretend city. And now what we can do is we can actually use the type function, or the type function. And we can put in the house variable. And if we run that, the result is str. And that is what Python represents as a string, is an str. Okay, so let's move on to concatenation. So concatenation in programming is basically when you have two or more strings, and you want to have one string from that. So you want to add them kind of together into one string. So let's really quickly just create some code here. So let's say we have two different strings. Let's have a prompt. My name is, and then we'll have an answer. Eric. And let's now print prompt plus answer. So it's kind of like adding strings, and we'll see what the result of prompt plus answer is. Now, in concatenation, the order in which you define these does matter. So notice how I put prompt first, and that's this variable here, and then I put answer, which is this variable here. So what we should expect is that this variable, answer, comes after prompt, which in practice means that it'll be more to the right, and you'll see this when I run this code. So my name is, which is the prompt, as we can see, is on the left, and then on the right, Eric, which is the answer variable. So let's maybe look at another example of concatenation. Let's say we have three different strings. Let's say we have a string 1, or maybe let's call it variable 1, var1, and that's going to be 12. And this is to show you that characters can be, they don't have to be letters, they don't have to be just things that you would see in a word, or like space, for example. They can also be numbers, and they can be other characters like the @ symbol, or like quotation marks, as we saw earlier, or even asterisk, ampersand, any of those special characters. And we'll look at some more interesting characters later in this episode. So let's say var2 is going to be equal to 6. And you still have to put those in the quotation marks. I'm using the double quotation marks because they deal with that one case where you want to have an apostrophe. And it's not very common that you'll use the triple ones. So that's why I'm using these ones most of the time. Then we'll finally have var3. And var is short for variable. And then we'll have the result of that, of the addition of the first two variables, which is 18, in string form, of course. So some mental maths. And what we'll do is now we'll have var4, variable 4, and we'll make it equal to var1 plus, and then we'll have even another piece of text inside some quotation marks, some double quotation marks. So you don't have to use predefined variables. You can also have you can also create variables on the fly. So this would be kind of like, you could imagine it almost as creating a variable on the fly. You're creating a string, basically. So we're going to say variable 4 is equal to variable 1, and then the string plus, so the character plus. Then we're going to have variable 2, and then another plus, equals, and then we'll have variable 3. So what we're basically saying here is that we want to create a variable, which is a string, because we're going to be using strings here. And that's how Python figures it out. So we're creating a variable 4, which is going to be a concatenation of variable 1 on the left side. So this variable first, so 12. And then we want to have the character plus. So that's the symbol plus. And when you do concatenation, it creates one string, right? That's the result of concatenation. Then we're going to have variable 2 added to that, so we're going to have 6. So far we have 12 plus 6, and you can kind of see where this is going. We're going to add another character, equals. So 12 plus 6 equals, and then we're going to add variable 3, which is 18. So now what we can do is we can print variable 4 and see what that looks like. So hopefully the result that we're looking for is that it's going to show us the calculation 12 plus 6 equals 18. So let's see. And that's correct. That's what it shows us. So awesome. Let's move on to the next topic. And the next topic is string slicing. So string slicing, as we mentioned earlier, a string is kind of like a long chain of characters, right? And each has their own, it's in a specific order, right? Let's say you have a sentence. If each word was in an incorrect order, the sentence wouldn't make much sense. So it makes sense that we would have to have an order for each of the words, or in this case, the characters in a string, as we would for the words in a sentence. So each of these, we can assign them a number. Like, for example, when you're looking at a sentence, the quick brown fox jumped over the lazy dog, for example. We can say that the would be the first word, right? And then the quick, so quick would be the second word, brown would be the third, and so on and on. In Python, it works very similarly with the characters in a string, except that we start counting from 0. So we call this indexing, and we would say in Python that indexing starts from 0. And why we call it indexing is that each of these identification numbers, or like the order of each word or character, is called an index. So that's kind of the how you identify each character in a string. So there's a specific format that we use for string slicing in Python. You use a pair of brackets, open and closed. Inside, there are 3 parameters. That is the start parameter, and this is the first character in the string, the index of the first character in the string that you want to start from. There is the end parameter, which signifies the last character that you want to access. And it's important to note that the range that this creates from start to end, it only includes the characters from the start to the end, but not the end index. So let's say we had the word apple. Apple is made up of 5 letters, A, P, P, L, E. So let's say if we used the index 0 to 4, since indexing starts from 0. And so you can kind of say, like, I want to access the first letter and the fifth to the 5th letter. So so in this case, Apple has 5, right? You minus 1 from that, so 0th to the 4th. What this would do is it would access actually A, P, P, L, but it would not access the E. And why is that? That's because the final letter is not included. What you need to do is you need to say 0 to 5, and then it will access everything. And finally, skip. Let's say you're going from the beginning of the word, you're going character by character. So let's say you start from 0. If the skip was 1, you would only move up by 1. So you would visit each letter. You'd visit every letter. You'd start from 0, then you go to the first letter, then you go to the second letter, then the third letter, in order. Let's say skip was a different number, like 2. You would visit every second character. That would mean that you start from the 0th, then you go to not the first, but the second. And then from the second, you don't go to the third, but you go to the 4th. So you basically, the skip value is which nth character do you access each time. And the final thing to mention is that in string slicing, similarly to having indexes from the beginning, from 0 to whatever number of characters you have in your string, that you can access each character using that index. You can also access the characters from the end of the string using negative indexes. So this would start from -1. So the last character in a string would be the -1th character. which can be a little bit confusing, but we'll go through some examples. So hopefully that should sort of demystify it. So let's create some code here. Let's say we have some text. Let's use hello world since that's a classic. Now, let's say I want to access the first word, just the first word of that. I know that hello is made up of 5 letters, and as mentioned previously, we can access the first 5 letters using the indexes 0 to 5. So let's print, and then we want to access the variable text, and we want to access the positions 0, and then we use a colon, 5. And you can put a colon here 1 to mention that you want to visit every character. Usually you just leave that empty and Python will do it automatically. So it kind of assumes that it's 1. It does the same if you leave out other colons, and we'll look at that later. So let's just see what the result of this is. So it printed the text hello, which indeed are the first 5 letters of the text. There's another way we can do this. What we can do is print, and we want to access the text variable, and we don't want to paint, we want to print. And what we want to do is we want to leave it empty, the empty colon, and then 5. And so Python will automatically assume that this is starting from 0. Same as it would if you were to set the skip to 1, we'll leave it empty, as we just saw. Let's create some more text and play around with this a little bit more. Let's say I want to access the second word. So characters can represent a large range of different symbols. That includes so-called white space characters or empty space characters, such as space. So I'm selecting it here. That would be considered a character. So let me use the same text here. And let's say now I want to access, let's create a variable to access this. Let's call it a slice, slice1, is equal to text. So the text earlier, that's this variable that we created here. And we want to access these positions. So we know that this variable, or this character here, this is the 5th characters. So let's start from here. We go 0, 1, 2, 3, 4, 5. And since we don't want to include the space, we're going to go to the 6th character. And we want to go to the end. So we're going to count up 7, 8, 9, 10. And that seems to be the length of this string. And since we want to include the last letter, we're going to write 11. So now let's print slice1. And we can see that it was a success. We printed the final word. And if we select this, we can see that there is no space. Let's really quickly experiment with this, and let's just try 5 to 11 first, and you'll see that the space will be included. So that just moved a little bit to the right. That means that there is a space there. Let's go back to 6, and let's try 10. Let's see what happens. So remember that the D is the 10th character here. So just to show that this is non-inclusive, that means that the final character isn't included in the range. I'm going to use the 10th index and see what happens. And as you can see, the D has not been included in the result. You can also do something like this. Let's say we have slice 2. And let's say we want to access the final word. You can also do 6 colon, like an empty colon. And just as in the previous example that we had here, it'll automatically assume that you mean that you want to go to the end of the string. And if we print that, this is what it'll look like. So as you can see, it's the same result. In case we don't know the length, or we just want to access the until the end of the string, you can use this notation, this kind of syntax. Another interesting thing to note about slicing is that you can actually access a single character of the string, and we can do it like so. Let's use the text. Let's use the text variable that we created earlier. Let's create a new variable. Let's call it character1 because it's a single character. And we want to access the first character we want to access the first character in the string. And we know indexing starts from 0 in Python. So we'll access the 0th character. That should be H, because that's the first character. And now let's print this. So as you can see, H has been accessed. Let's try one more character just to see what happens. Let's say we want to access this O over here. So what we can do, so we know that that's the 4th character in the string, starting from 0. And what we can do is we can print that. And as you can see, we have an O as an output. Let's move on to slicing with negative indices. This is something that we mentioned before, and I think the first thing I would like to look at is what a negative index kind of is. So let's define some new text, something more interesting. So lorem ipsum is a kind of filler text that you see in a lot of demos and websites, like early dev builds. We're just going to use that. Let's say we want to access the last character of that, so that'll be an M in this case. So as we mentioned earlier, negative indexing is a lot like regular indexing, except for instead of starting from the beginning of the string, you start from the end. And since 0 is already the beginning of the string, we use -1 to assign the final character. So let's just see what that looks like. And we want to use text2 at position -1, and we're going to see what that looks like. So text2 is this variable that we assigned here. And let's run this and see what happens. So we should expect to see an M as the output. And that's exactly what we got. We got an M. That's really cool. Awesome. So let's now try accessing up to a character from the end. So let's say print, and then we'll say text2, and we want to go from the -5th character. So if we go from -1, 2, 3, 4, 5, that's ipsum. That's the -5th character, so I, until the end. And since we're putting this at the start, and we have this notation that we used earlier, it should assume that we're going to the end of the string. So let's run this and see what that looks like. We should see the word ipsum. And that's exactly what we get. Awesome. So let's say now I want to go from the first character, so the 0th character. And since in Python we don't need to specify that, we can just add a colon there, as it assumes we're going from the first character. And we want to go up to ipsum. And let's say, actually, we don't want to include the space as well. So we know that's one more character to the left, so let's go to -6 as the index, and let's print that and see what happens. So we should get the word lorem, because that's at the beginning to the -6th, which is from the end, ipsum including the space. So let's try that. And we get lorem. Awesome. So we can see that that works. Now let's say I want to access the 3rd character from the end to the 2nd character from the end, but not the first character from the end, or the final character. Let's see how we can do that. So let's print, and let's access text2. And we want to access the 3rd character from the end, so -3. And we want to go to the 2nd character from the end, so -2. And it's very easy for you to get confused with indexing starting from 0. Just remember, for negative numbers, indexing is normal. So it starts from 1, or -1 in this case. Always remember the negatives. So what this is saying basically is we have the start and the end. We want to start from the 3rd character from the end to the 2nd character from the end. And let's see what that looks like. We should get SU, since this is the 3rd character from the end and U is the 2nd character from the end. Okay. And it's important to note as well that as with regular indexing, the end is not included, so it's non-inclusive. So we should actually put -1 here, and we should get SU. Okay, awesome. So now let's do slicing with skip. So as we mentioned earlier, if we go up here, the notation is start and skip. And skip is kind of the, like, how many characters do you move by to create the final string. So let's create a new code statement here. Let's create a variable. So let's say we want some more text. And we're going to say the real folk blues. Okay. So so what we want to do now is, let's say we want to access every second character. So let's create a variable called every other. And what we want to do is we want to access the variable text, and we want to access the entire string. And what we can do is actually we can, as we mentioned earlier, if you just include the colon, Python will assume for the first one that you're going from the beginning and for the second one that you're going to the end, right? So the entire string. And now we add a second colon, and this is where we add the skip. So for the skip, we want to access every second character. We'll do it like so. And I want to print this every other, and this should print every second character. So let's just look at the first few to kind of get an idea of what this should look like. So we should have a capital T, a lowercase e, then an R. So we skip over the space. We skip over the E, we get an A. So far we have T, E, R, A, and then we should have a space, because spaces are also counted. We skip over the F, then we do O, and so on until the end. And let's see what that looks like. Oh, Terra OK bus. Okay, awesome. So that's every second character. Let's say I wanted to do every third character. So let me create a new area here, and let's say every third. And we're going to say we want to access the text variable. Then we want to access the entire string, and we want to skip over every third. And now let's print that every 3 characters. And really quickly, let's just look over what that would look like once again. So essentially you skip 2, and then the third character you would print. So you would get T, skip over H, skip over E, then you have space, skip over R, E, then you have A. So T space A, skip over L and space, you have F. So T space AF. So let's see what that looks like. Okay, so we have T space AF and then KLS. Okay, so let's say now we want to access every so-called even character. So let's assume that each of these have a number that doesn't start from 0. Let's say the first character would be number 1, the second character would be number 2, as you would expect, right? And let's say we want to access the characters with only even numbers. So in this case, let's create a character called even characters. And we want it to be text. And what we want to do is we want to, just like before, we want to access every second character. But notice that Python assumes you will start from the first character. It'll start from the 0th character. What we want to do is we want to start from index position 1, which is actually the second character. So we want to start from H, because T would have the index 0, which is an even number, but in reality it'd be the first number, which is odd. So every even character would be starting from the first position and then skip over every 2. And we can do it like so. So we have the start, the end, which is assumed to be the end of the string, and then the skip, which is 2, so every 2 characters. And let's print that to see what it looks like. And we should be expecting T, E, R, A, since those are the even characters. Oh, sorry, H space E, L, since those are the even characters. And we have space H, E, L, and then some other stuff. So that works. Okay, awesome. Now, I wanted to show you something very useful. Let's say you wanted to use skipping, but you wanted to do it from the end. So a really useful application of this is, let's say you want to start from the end and you want to go to the beginning. In other words, you want to reverse the string. So how can we do that? Reversed text is equal to, and we want to access the text variable. So that's this one here, the Real Folk Blues. And we want to reverse it. So we want to access the entire string. So as we said before, when we're accessing the entire string, you just use 2 colons. And then you want to go by, you want to move by -1. And what this will do is it'll start at the end and it'll go backwards. And what you get is a reversed string. So let's see what that looks like. So we should expect SEULB first, and then the rest of the text backwards. And that looks like SEULB, and then the rest of the text backwards, including the spaces, which is really cool. So let's try one more thing. Let's create a palindrome, which is a word that's the same backwards as it is forwards. So for example, race car. So race car is the same forwards as it is backwards. You can pause the video and test that theory if you don't believe me. So what we want to do is we want to print palindrome, and we want to use the same method as we used before. So access the entire string and then move by -1 each time. So let's run that and see what happens. And we get race car. So we have proved just now with code that race car is the same forwards as it is backwards. Very awesome. Okay. So now we'll be looking at string functions. In Python, there are a number of built-in functions that allow you to play with the strings, to access different parts of them, to manipulate them, or to interpret them, to see properties of them. So it allows you to see some properties of them as well. Let's look at this first function here. This is the len function. And len is short for length, basically. So let's say I have a word hello. So let's define a variable word hello. And what I want to do is I want to get the length of this word. We know that this word is 5 letters long, 5 characters long as well. So let's get length, and we'll set that to, and we'll use the length function, so len, and inside we want to put our variable word. So this function is going to take our variable word and it's going to give us an integer or a number, basically, which is the length of this word. So let's test that real quick. So we know that hello is a 5-letter word. Let's see what we get as soon as we print it first, maybe. So let's print this and see what we get. And we get 5. Awesome. So that proves our theory that hello is a 5-letter word. Let's try now seeing what happens if we have an empty string. So empty string is equal to, and then we put nothing inside the quotation marks. Or maybe let's use these quotation marks. Why not? We haven't used them very much. And then we'll get length is equal to the length of empty string. We'll print length, and let's see what we get. And 0, we get 0 because it has a length of 0. There are 0 characters in this string, which is correct. There is nothing in there. I also wanted to demonstrate what happens when you have spaces inside of a string. So they're also counted towards the length. Let me create a string here. String with spaces. And I'm going to define the quick brown fox. And now what I want to do is length is equal to the length function of the variable string with spaces. And now let's print that variable, or let's print the length, and let's see what we get. 19. Okay, now this doesn't really prove anything. What I'm going to do is I'm going to remove the spaces here. So we had the result of that being 19. That was the length of the string. If we run this code again and the length changes, that means that the spaces were actually included in the length. If it stays the same, that means that it did not count the spaces. So let's test our hypothesis. And we get a number 16, which is 3 fewer than 19, which means that it did indeed count the spaces in the length function. This function is called ends with, and it returns a boolean, which is a true or false variable. This can have 2 values, essentially. So what this function does is it tells you if the string you have ends with another given string, so another string that you give it. So let's create a string just to test this out. Let's create a variable. Let's say text is equal to, we'll have 33 spelled out. Now let's say we have another variable, a is equal to 3. We'll have b is equal to the number 3, and then we'll have c, which is equal to 2, spelled out as a. Now let's get a result variable, and inside this variable we're going to store the boolean that we get from the ends with function. So let's access the text variable that we created earlier. This has all of the text that we have, so 33 spelled out, and then we're going to use the ends with function. Inside that we're going to test for a. So what we're doing here is we're creating this variable result, and we're saying this variable is equal to the result of the function ends with testing for a, so 3, applied to the variable text, which is 33. So what we're saying is result, this variable result, is equal to if text 3 ends with a, which is 3 spelled out. So we know that it ends with 3, so we should expect a true result. Let's test that. And we need to print that. So print result, and we have true. Let's test for these other variables here. So result is equal to text dot ends with b. And let's just print that, print result, and let's see what we get. We should get false, since we know that this is 3 spelled out, and this is 3 the number. So we should get different results here. False. And now let's once again access result. Let's say it's equal to text dot ends with, and then c, so we're testing for the c variable. And let's print that result. We should also get false, since we're testing for 2, and this ends with 3. And that's exactly what we get. There's another thing I wanted to test out. Let's print the result of testing the variable text. Let's see if it ends with 3 spelled out with a capital T. And that's false. And you might be surprised, but because we used a capital T, it is technically a different character. So these functions, we could say, are case sensitive. That is, the case of the letter, so whether it's lowercase or uppercase, capitalized or not, actually affects the result of using these functions. And it's the case with a lot of the functions, so keep that in mind. There is also a starts with function, which works very similarly, but from the start of the text. And we can just really quickly test that out as well. So let's print the result of testing text, the variable text, and then we're going to see if it starts with 30. We should get true. And that's what we get. So you can extrapolate, you can guess what would happen if I applied this with a bunch of other cases, but I think I'm going to move on to the next function. So we're going to look at the count function now, and what the count function does is that it looks through the string, and you give it another string, and it'll tell you how many times that string shows up in the first one. So let's say we have a text, and let's say the quick brown fox jumps over the lazy dog. And we want to have a new variable result. Let's call it result, or we can even call it variable 1. And we're going to say, and let's say that it's equal to the result of testing the variable text with the count function. And let's count how many spaces are in this string. And now let's print the result of that. And we should get, let's count quickly, 1, 2, 3, 4, 5, 6, 7, 8. So we should get 8 as a result. And that's exactly what we get. Awesome. Now, it is said that in the English language, E is the most commonly used letter. So let's test that hypothesis. Let's use the text variable. And we want to print the result of testing the text variable with the function count. And let's count the number of occurrences of the character E. So let's test that really quickly. And we don't want to pint, we want to print 3. Okay, so there are 1, 2, 3. Let's finally test one more thing, and let's print the result of text. We want to access text variable, and we want to count the number of occurrences of the word fox. And we know that fox only appears once in this entire sentence, right? And so we get the value 1, correct. Another thing I wanted to test is the result of testing the variable text and seeing how many occurrences of the word the are inside of this string. And we get 1. Now notice that because the first letter here is lowercase, it does not count the first letter here, with a capital. So just once again to show you, these functions are very case sensitive. So keep that in mind because it's sometimes easy to forget when you're programming. Okay, we're now going to be looking at the capitalized function. And you might think that what this does is it turns every character in the string from lowercase to uppercase. But what it actually does is it makes the first character uppercase. And if it's already uppercase, then it stays the same. So let's say we have a string, text, is equal to proper names should be capitalized. And we're going to have another variable here, and we have lowercase. So let's just concatenate those real quick, see what we get. And we get proper name should be capitalized Amir with a lowercase. Now let's fix that. Let's take this name variable and let's add dot capitalize. So we want to apply, when we're using this dot, we want to apply the capitalized function to this name. And it is a function because it returns this string with an uppercase first character. So let's see what that looks like. Let's run this. And we can see now that the first letter of Amir has been capitalized. So the function works as expected. Let's try one more. So let's use the quick brown fox jumps over the lazy dog. And we want this sentence to be capitalized. So let's turn it into a proper sentence by creating a variable called proper sentence. And we're going to say that this sentence, this proper sentence variable, is equal to sentence with the function capitalized applied to it. So we're going to capitalize the first letter. And now what we want to do is we want to see the result of that. So let's print proper sentence. And let's run this code to see what happens. So we can see it's been transformed. The first letter is now a capital T. So very cool. The function works. So now let's look at the find function. This function is a very interesting function. What it tells you is the index of the character in the string that you're looking for. As we discussed earlier, each character has its own unique index in a specific order in the string. Let's note some of the interesting properties of this function. One of them is that, as with other functions applied to strings, it is case sensitive. So if you have a lowercase e that you're looking for in the sentence, it's going to skip right over all of the capital E's. Another interesting property is that if you have multiple characters that you're looking for, it'll return the first one in the string that it finds. So let's say you have a lot of E's. As we know, E is the most common letter in the English language. If we applied this function to, let's say, a long piece of text, we might be disappointed to find that since it can only return one integer, one number, one index, and let's say the sentence starts with the word the, it would return 2. It would return the first E that appears in that sentence. So the final property I wanted to talk about is that if the thing that you're looking for, which can be either a character or it can even be a string, so a word, for example, or some other combination of characters, if that is not found in the string, it'll return a -1. So that's how you can test for that. Let's test this out. Let's create a text variable. Let's use some Latin here. And what we want to do is we want to have, let's find the location of E in this string. So E location is equal to old lie dot, so applying a function find with the parameter E. I'm going to put that inside quotation marks. So it's going to look for E inside of this string. And what we want to do is we want to print the result of that. E location. So we want to print the E location variable. And we run this, we get 4. And to test if this worked correctly, let's start from the first character. And as we know, indexing starts from 0. So D would be 0, U would be 1, L would be 2, C would be 3, and E would be 4. And let's check over here. We have 4. Okay, awesome. So we know that it works. And as you can see, there are multiple E's in this text. There's one here. There's one here. There's even one here, actually, that I missed. And it returned the first one. So it gave us 4. Let's say we're going to look for a word now. So as we know, this E here appears at the position 4. If we go one more character to the right, we get 5, and 6 is the position of the next E. Let's maybe test, instead of for this E, let's test for et, which is the second word in the sentence. Since it begins with this letter here, this character, which is at the 6th position, we should expect that we get a 6 as the result. So let's find et location is equal to, and then we have the variable old lie dot find, and we want et. And let's print that. And as we said before, we should expect a value of 6. And we get 6. Awesome. So we know that that works. Let's look for something that isn't in here. And something I definitely don't see in here is a random goggle of different special characters. So let's just try that out, just some random special characters, and see what happens. So let's create random characters. Not truly random. We are making these up. We could also just use something that doesn't appear in the text, like ASDF, for example. Let's test it for that, actually. So let's print the result of testing the variable old lie, which has our text inside of it, with the function find. So we want to find something inside of that text, and what we want to find is random characters, the variable random characters, which is ASDF. So if ASDF appears at any point inside of this text, we should see a index of it ranging between 0 and infinity. Note that in real life, you would not find a string with an infinite length due to the limitations of physical hardware, so that wouldn't be possible. But let's see what we get. And we get a -1. And as we discussed earlier, what this indicates is that it was not found in the string. So I think this actually covers all of the cases that we've covered previously. Let's move on to the next function. So let's look at the replace function. What the replace function does is that it takes one character or one string and it replaces it with another character or string in a given string or a given variable. So let's create a variable here. Let's call it text. And let's just write something, some filler. The quick brown fox. Awesome. With a full stop at the end. Why not? And let's say I'm really angry about this the not being capitalized. But I'm a bit more angry that it's not fully capitalized. So let's say I want to create a new variable and let's call it better text and is equal to text. And let's say we want to replace this the that we have with a fully capitalized the. So we're very angry here. And now let's print this and see what we get. So let's print better text, which is the new version, with replacing the with fully capitalized the, and let's see what we get. And we get the quick brown fox. Okay, awesome. Now, let's say I don't like this color, and I want to change it from brown to something more interesting looking. Let's say we have a bright orange fox. So orange text is equal to text dot replace. So we're applying the function replace, and we want to replace the first parameter, which is going to be brown. So with the first word, we want to replace the second parameter would be the word that we want to replace it with. So we want to replace brown with bright orange, maybe neon orange. And now let's print the result of that. So print orange text, and we get the quick bright orange fox, which is exactly what we're looking for. So that's pretty cool. Another thing you can do is you can actually replace things with an empty string. So let's say I don't like these spaces. I want to get rid of all of these spaces. What I can do is I can say text without spaces is equal to text dot replace, and we want to have spaces. So we have a space character in there, and we want to replace it with an empty character. Let's print that and see what we get. And we get the quick brown fox without any spaces. Let's take a look at escape sequence characters. Escape sequence characters are a kind of special character, and in programming what we use these for is certain situations where we want to represent a property of a string, and let's say we want to designate characters to letters and numbers and all that. But when we want to represent one of these characters, what we do is we use a backslash. So they actually take up two characters. They use a backslash and then another character. So backslash followed by another character, but they represent one character. So the first one of these would be a new line. And what this is essentially, let's say you have a sentence or a paragraph, and when you read text, when it reaches the end of the screen, usually it goes back to the left. That would be a new line. So a new line is created. A tab is a large space separating two parts of a string, and let's say now you want to use this backslash in the text, but it's reserved for escape sequence characters. So what we can use is a double backslash, and that'll just include the backslash in the text. Let's try this out. So let's create a string. Let's call it string1. And let's say it's hello world. And then we want to say this is a new line. So notice I put /n here, and my environment, Visual Studio, is showing it in red, and this is to show that it's an escape sequence character, it's a special character, so it's being treated differently. So what will happen is that when this text is printed, what you'll see is actually that these two pieces of text separated by this escape sequence character here, by this new line, will be on two different lines. And let's test that out. Let's test out that hypothesis. Oh, so we can see hello world, the first part, is on its own line, and then this is a new line, is on its own line. Now, I want to try something really cool. I want to show you a cool application of this. Let's say we have a lot of text here. Let's say we have string 2 is equal to hello world, how are you today? And let's say I want to print every one of these in a new line. So what I can do, let's create a variable called separated, and we want to access string 2, and we want to replace space with this escape sequence character. So /n. And now let's print this variable. And what we get is hello world, how are you today? And you can see these are all on their own lines. So I replaced these spaces with /n's. And just to show you what that would look like, let me replace these manually. And we should get the same result. And let's just print string 2. And let's see what we get. And we get the same thing. So that's just one way of doing it. Put this back to how it was. Awesome. So let's look at tab. What does tab do? Let's say we have words, 2 words, and we're going to say, hi, mate. And let's say I don't like the space, it's too short. Let's add a tab, so /t. And now let's print this. And what we get is a bigger space, hi, mate. You can see is much larger than a space. And this is usually used for separating different content inside of a string. Let's say we want to do something similar to what we did before. So let's take this string 2 here. Let's copy it over here. Let's call it string 3. And let's say what we want to do is we want to have a new variable called widely separated. And we want it to access string 3. And we want to use the replace function. And we want to replace the spaces with the escape sequence character for a tab. So that should basically widely separate our text. And let's print this, of course. Now let's see what that looks like. And you can see now each of these words has a very big space in between them. Okay, let's look at backslash. So if I try to just create a piece of text here with backslashes, this text has a backslash. Instead of an L, I'll use a backslash. And what you'll see is that Python automatically thinks this is another kind of escape sequence character. And if I try to print this, let's see what we get. Oh, you can see there's a special character here, and we don't want that. We just want to have this with a slash. So what we can do is a double slash here, and it'll just replace that with what we wanted, which is a slash. So a slash instead of an L, in case you wanted to write in a quirky style. Let's move on to raw strings. Another way that you can deal with these backslashes and escape sequence characters being interpreted differently by your IDE or your environment is you can use raw strings. So let's create a string here. Let's violate all of the rules. So the way you do this is you place an R before the quotation marks, and let's say now I want to create a string, this text, and then let's say we have a /n. So this would create an escape sequence character for a new line, has /t. This would create a tab, so a very big space. Escape sequence characters. And now let's have a double slash. So there should be one slash only if we're using escape sequence characters. And let's print this. And what we should get, what we should be expecting is that to be a line break here. So these lines should be separated. We should be expecting a large space between has and escape. And we should be expecting one single backslash here at the end. And what we get, we get the exact same thing that we wrote in between the quotation marks. And that's because raw basically tells Python, okay, it doesn't matter what backslashes we have. It doesn't matter what you think the escape sequence characters we have. Pretend they don't exist and just write exactly what I wrote in between these quotation marks. So this is useful if you want to use these characters in your text and you don't want Python to interpret them differently. This is how you would deal with that. We'll talk about some applications of this later in this course. Let's take a look at the final part of this episode, which is string interpolation. And that's a very fancy way of saying, Okay, strings are awesome, and I get that I can concatenate different things together, but it kind of takes a long time, and I want to do it in a more intuitive way. So it takes a look at that problem and it says, oh, I've got a great solution for you. And what this is let's say you have some variable that isn't a string, and Python has a way of converting these into strings, which you might have seen in previous episodes, and it uses a lot of syntax and it's very bulky. So what you can use is string interpolation, and Python will automatically convert those strings for you, and everything will be positioned in a very intuitive way. So one of the ways of doing this is with f strings, and I think the best way to explain this to you is just kind of by showing it to you. So let's say we wanted to follow in a previous example. Let's have a prompt. And let's say my name is, and let's say I wanted to put my name afterwards. What we would do is we would have a plus here, and we would have a variable called name, and we would add that. But let's say I want to do it differently. Let's say I want to have it inside. What I have to do is I first have to define a name variable. So let's say the name is, well, my name is Eric, so let's put that in here. And I want to say my name is, and what you have to do is at the beginning of one of these strings, as with the raw strings, you put an F, so it's an F string, you put it at the beginning, and what you can do now is you can use braces, which are these squiggly kind of brackets or parentheses, if you want to call them that, and then you put the name of the variable you want to put in that. Python will automatically convert that for you, if it can be converted, into a string. And let's print this to see what it looks like. So let's print prompt, and it should say my name is Eric, and let's see what it says. And it worked. So this is a really cool way of doing that. Let's look at some more examples. Let's say we have some operation that we want to track, right? So let's have a variable 1, or maybe let's for simplicity call it A, and we'll have 12, and then we'll have another one called B, and we'll have it B equal to 6, and we'll have C equal to 18. So we kind of have done this operation before. Let's see what it looks like. We'll have a variable D is equal to, and we're going to create an F string here, and we're going to say the variable A inside these braces, and we want to have the character plus. So everything that's in the braces will be treated as a variable, and everything outside of the braces will be treated as a character, including these spaces, including these characters like plus. We'll have another variable B, and then we'll have the character equals braces, and then C, the variable C. And now we should have a cool string which has all of these variables inside it, and is a much simpler way of kind of having variables inside of your text. So let's print D just to see what that looks like. And we have 12 plus 6 equals 18. So that's a really cool application of this. Okay, so that is the end of this episode. I hope you guys enjoyed this. Make sure that you like and subscribe to the video. Within the description, there are some links for you to access the website, Aorb Tech, for this Python course and for many other courses that we are working on. There are also some of our social media sites and sources, and there is a link to a GitHub repository with some code, with some comments so that you can read through and you can look through. So it's a sort of better version of this notebook that I prepared beforehand. I created some really nice examples for you guys to look at. So if you're still confused, if you still need some help, you can write some comments in the description. We'll try our best to help you out. Accessing the GitHub is also another great way of revising and testing your knowledge and checking it. And you can actually open up these notebooks and you can play around with them so you can test them like I've been testing here. You can write some stuff down, you can run the code and see what happens yourself. So that's a really cool way of improving your experience. So thank you for watching, and we'll see you in the next episode. Bye-bye.